All right, thank you. Can everyone hear me okay? All good? Okay, great. So hello everyone, and thank you for being here. I'm really super grateful for this opportunity. So I'll be talking about containers today. So there were a couple of talks about containers already. Hopefully you'll learn something new. So that's my goal. So how many of you use Docker regularly for containerization and everything? Okay, quite a few. So by the end of this talk, I hope you have a better intuition about building more efficient containers, and for your Python apps, specifically. Okay. So the way it will go is that I will actually go over a sample Python application which I built. Okay. Go through the base Docker file for it, and then we'll try to improve it over time and see how we improve the numbers, improve the image size, and the build times. Okay. So let's get started. I'm so glad the sun is out. Yeah, hopefully we'll have a better energy. Okay, so a little bit about me. So I got introduced to Python in 2013. That was mostly about the data science and aspect of things. So currently I work as a staff MLE at Intuit, where I lead AIOps efforts there. I love RPG games, by the way, especially in PS5. Any Last of Us fans, hopefully, yeah. So I love it. And hopefully I want to become a yoga instructor in the near future. So fingers crossed for that. So without any further ado, let's talk about the motivation behind why are we really talking about images and containers. So we all know that shipping applications in productions using Docker is kind of like a go-to right now, especially when you use something like Kubernetes with it, right? Now the good thing is that building an image for a Python application is actually pretty straightforward. It's not that hard to set it up and get something running. The tricky part is to really optimize it for your application for faster build time and smaller image size. So we'll go into all of that soon. And this is even more complicated when you have something which has a non-Python dependency. So maybe something like a C extension, C++, or Rust. Okay, so let's go over a little bit about the basics about what is a container. We'll just skim through it. I'm sure many people know about it. So a container is basically, it's about packaging the application with all of its files, configs, and dependencies, and run that in isolation. Okay, so that's all it is, right? But what about an image? So an image, so the way I like to think of it is the image is like an instruction template. Okay, it's an instruction. It's actually a set of instructions on how to run this whole container. So it has different layers that depend on top of another ones, where we can add, remove, run things, all of that, and it's written in a file called Docker file. And the benefits are portability. So it's very portable, which means that you can just copy from one machine to another with a different architecture. You might have to change a little bit, but otherwise it's pretty portable. Isolation, because you're able to isolate your application from any other system processes. Then you have scalability, of course, especially combined with something like Kubernetes. It's very, very scalable. Now, it's also deterministic, so it's reproducible, right? Well, at least it's supposed to be. We'll see in a second that sometimes there are some gotchas there, right? And it's very lightweight compared to a traditional virtual machine, right? Because it's just a simple Linux VM which is running in isolation. So compared to a traditional virtual machine where you have a full-fledged OS running, it's very, very lightweight. Okay. So why should we really care about making better images? Why are we really here, right? So the main thing that we need to think about is that if our images are not really efficient, that will lead to slower build times. And slower build times will affect the way developers ship things to production. So it will decrease the developer productivity, okay? And as well as it's very difficult to fail fast, which means you have to wait for your code to really build in order to really test what is going on and if things are running or not. Then there's the obvious thing, which is the larger image sizes. So if we have a really huge image, it will require more storage, it will have longer download times, and if you have a CI/CD setup, it will really take a long time for that image to get pushed as well. And of course, there are some security risks as well. If you're not careful, for example, you're using a very outdated base image with, let's say a very older version of Debian or something, then you will have some security risks as well. And of course, if you're really not careful, there could be a performance overhead as well. Okay, and by the way, this is very easy to make this mistake about the large images there. So when we talk about efficiency, right, how do we really measure it? So for this talk, I'm going to focus on 4 different metrics. Okay, so we'll go over them. The first is the biggest one, which is the uncompressed image size. Many times when you see, in many of the portals like Quay or maybe some Docker, right, you will see the compressed image size, but we're talking about the uncompressed image size. So that is the one that is the most important. Okay, so this is our biggest metric. Then we have the initial very first build time. So this is the one where we have no caching. Imagine that you're building an application, right? And you are just building it for the very first time. So you don't have any caching whatsoever. Then the rebuild time after a code change. So of course you're developing, right? So you will have some code changes. So how does the rebuild time work after any kind of a code change? Okay, and the rebuild time after a dependency change. So let's say you installed a new package or you deleted some package. How does that affect? So we'll focus on these 4 metrics and we'll see how that goes. So our example application, this is what I built. And by the way, this is all there on GitHub. So, so we'll give you the link later on. So it's a fast API based machine learning application, which runs on which uses the very famous MNIST data set. MNIST is the handwriting digit recognition. So I just trained a very simple convolution neural network in PyTorch. And but the main thing is that I included a very simple C++ extension. So this small extension will make the image building a little bit more spicy. Okay. So this is how our C++ extension looks like. Okay, so on the right, you have our classify image function, which basically does take the image. So I'm going to take the digit, right? So maybe it's 4 or 5. It takes the image, converts that to a tensor. It loads the model and then runs it through the prediction. Okay, but the output that we get from the model is actually a softmax output, which is a fancy way of saying that there are 10 digits, right? So you have 10 different outputs, each of them summing up to a probability distribution, and you want to take the one which gives you the maximum probability. So in this case, we'll have to use the argmax function. Now, instead of using the usual torch.argmax, I'm going to use my own extension where I wrote this in C++, and it does the same thing. Okay, it just adds a little bit more complexity there. Okay, so we're good here. So let's get started with building our first Docker file. Okay, so our, I would say the full directory structure looks like this. So we have a Docker ignore file, right, which is very important, which is similar to git ignore, and it's very important so that you don't copy some unwanted dependencies or unwanted files or caches, right? So you have Docker ignore, you have our Docker file, we have the artifacts, which is our model, we have the extension directory. This is where I actually store the argmax.c++ file, and then I have the setup py to build that extension. Then I have some PyProject toml, and then some requirements files, and then I have my source code, right? So all is good there, and I have my requirements.txt as well. I have hard constraints in the requirements file for deterministic behavior, right? That's what we want, so which is good. And by the way, this approach that I'm going to take is just one of the approaches. You can do it in multiple ways, but hopefully it will make things clear on what to focus on. Okay. So this is our initial Docker file. So I'll just go over it very quickly, actually, since we are short of time. So on the first line, we are basically basing from a base image, which is the Python 3.12 bookworm. Bookworm is the latest Debian version. We set up some environment variables where we say the default timeout, and we disable the version check because that will just increase the build time. Then we are in the app work directory. We copy the source files, we copy the requirements and the extension folder, and we then install the dependencies. Okay. In the end, we have the command for actually running that fast API application. Okay. So we are actually doing a lot of good things here. So we have a Docker ignore file, right? We are actually basing from a very good image. Okay, this is the latest Python, the stable version at least. Well, as far as I know. Okay, and then the bookworm, which is the latest stable Debian version. Okay, and we are also freezing the required packages, so which is very good. Okay, but the best part, it works. So this thing works. Okay, so it's great. And this is our performance. So we talked about the 4 different metrics that we'll go over. So this is our performance here. So the image size is a whopping 1.85 gigs. Okay, that's pretty big. So that is something we have to really work on. The build time, it's about a minute. So it takes this much time to build it the first time, which is why it's without a cache, right? Then we have the rebuild time without any changes you make. Now this is where Docker is very powerful because it can really cache things up, so you don't have to spend any more time if you are just rebuilding the same thing. Okay, so it's just 3 seconds. Then rebuild time with code change, it still takes a minute. So every time you make a code change, it will take a minute for this to be built again, and this is where we need to fix next, right? Then we have the rebuild time with dependency change. So anytime you add a package, anything, so it will also require something. So it would also need a minute of change there, right? So in all of this, right, what do you think is the slowest step of the whole process? Yeah, exactly. So it's the installation. So these installation is actually the biggest. So it's the slowest step of the whole process, right? So the bad thing is that the image size is about 1.85 gigs. Now builds are actually non-deterministic here, and I'll come to that just in the next optimization. But the first thing that we need to really fix is that dependencies are reinstalled for every code change. Okay, which is bad. We really need to fix this, right? So what do? We just change the order of operations. So instead of actually copying the whole source code into the app source, we just copy the requirements file first. We copy that, and then we install the dependencies. Now the cool thing here is that now, anytime we change anything in the source code, it will not get reinstalled again, right? So the requirements would not get reinstalled again at all, because everything above that is actually cached. That's how Docker layer caching works. So if there is any change at this point when we actually copy the source files, all the previous layers are actually cached. So we should be very quick there. So yeah, so we know this. And then if you look at the change in the performance, it's huge. It's huge, right? So we can actually rebuild with any code change in less than 3 seconds. That's amazing, right? Okay. But the bad thing is that, well, we did not do anything to improve the size of the image, right? We just changed the order. And then builds are still non-deterministic. Now, why do I say that? Now, the whole point of Dockers or the containers and images is to make things reproducible, okay? But this is a non-deterministic behavior, and the reason is, I guess many of you know it. It's basically due to the concept of transitive dependencies, right? If you recall earlier, we did have constraints on the requirements file. We did have that, but transitive dependencies basically mean dependency of a dependency. So I might have a hard constraint on a package A saying that this is the version that I need. Okay, really hard constraint. But that package A might have some loose constraints on package B. Okay, and so on. So this could actually go on a long time, right? So this is where we need to fix it. Okay, so which lets us to the next optimization, which is we actually pin the dependencies, right? So now we use some tool. So some packaging tool. It could be Poetry. It could be in PDM, Hatch, in pip tools. Just pardon me if I missed something, but really anything would work. Okay. So I use Poetry here to export the log file to a requirements file. So you see the requirements exported.txt. This is basically the exported requirements from the log file used by Poetry. But you could really use anything. Now, the second thing that I've done is separate the dev and the main dependencies, okay? Now, that is pretty important, because if you recall, I had some dependency like, Torch, Torch Vision, all of that, which are required, but I also had something like PyTest and Black. Now, those are basically dev dependencies, right? You don't need them. So we separated that out. And then I also disabled the pip cache, because you don't need really caching inside the image building process, right? So we did some improvements here, right? So the image size has reduced. It's still big, but it's still better, right? So the build time has reduced, and then the rebuild time also has reduced, right? So this is good. So we are going somewhere, right? But the bad thing is, the size is still big. So it's about 1.7 gigs. And yes, so we are going to tackle this, right? So let's tackle the elephant in the room first. Okay. So a very easy fix could be use a smaller base image, right? So if the base image is very big, then of course the whole image size will be big. Now, we were using the old image, which was Python 3.12 bookworm, right? But the problem with that image is that it actually ships with many things which we really don't need in production. So things like Git, curl, all of those things, like unless you need it, you don't need to install them, right? So let's use a slim image. Now, this one does not have all of those additional functionalities. So let's use that, right? So that should do it, right? Just use a smaller base image. But life is not that simple. Okay? So the problem is that we did not install any compiler to install the C++ dependencies, okay? So we'll really get a nasty error, and we have all seen those errors, I think, right? So that's the ugly part. This will actually lead to an error, because we don't have the compiler to install the C++ dependency, right? So we do something else. We now install the compiler. So here I run apt-get update, and I apt-get install the G++ compiler. And like a good engineer, I also remove it in the end. So that should be fine, right? I install the compiler, I install the dependencies, then I don't need it, so I remove it. So let's take a look at the performance. So by the way, this actually gives a lower base image download time as well, since the slim image is actually much smaller. So if you look at the performance, it's actually a drastic improvement. We went from 1.7 to 1.12. Okay. Now the build time got increased. I'm sure you can point that out. Like, how will that happen? That's because we are now forced to install the compiler as well. So every time we have to run this apt-get update and also the apt-get install G++, right? So this should be good, right? So I think this is where life gets easy, right? But the problem is, are we really removing the compiler in the right way? Okay, and this is where things get really tricky with Docker files. So the way the layering works is that layers are appended on top of each other. So here you can see that even though we are removing G++ in the end, we are not really removing it from the previous layers. And we need all the layers to actually get the final image. So the compiler needs to be fetched even though it won't be accessed in our final image. So due to this purge command, right? So we are not really removing the G++ compiler in the right way here. Okay? So what do? We now combine the layers. So let's combine the layers, right? So in one run command, now we have apt-get update, install, install the requirements, we run the setup, and we also remove the compiler, right? So let's see how the performance looks like now, right? We did improve a lot. So the image size is now less than 1 gig. The build time has been improved, and the rebuild time is a little bit, is actually increased a little bit. And here's the trade-off, right? It will always do the slow apt-get update in the compiler installs whenever there's a change in the dependencies. Because remember, we have combined everything into one layer, right? So there has to be that trade-off, okay? All right. So the not so good part, as I said, was that any change in dependencies will trigger all 5 of those run commands. Okay? So where can we go next? Or do you think is that it? Well, not so. Because Docker supports something called the multi-stage builds, where you have a builder and a runner stage. So the builder makes sure that he installs all the dependencies, and the runner just runs the application. Now, in a compiled language, it's pretty easy. So if you have a C++ code, let's say you have your file. So in your builder stage, you just install the compiler, build, compile the file. You get the executable. You copy the executable to the runner image, and then you're done. But here in Python, we have to copy the whole interpreter environment, right? But how do we do that? We are not using any kind of virtual environment or something, right? Because if you use the global Python package or the environment, it actually installs it in multiple different places, okay? So there's one way to fix it, which is either do a user-based install or use a virtual environment, okay? So we are going to use a virtual environment here. Okay, so if you look at here, we actually are installing in a virtual environment, and then we are copying the requirements as before, and we are installing all the requirements, and then just installing the dependencies in the environment. Okay, then in the runner stage, what we are doing is we are just copying that virtual environment in our path, right? And finally, we copy the source, and then we're good. Okay. So there are very good things going on here, right? Because dependencies are installed in a virtual environment. The builder takes care of installing the dependencies, which is needed, and then the runner is only responsible for running the application. Now, another good point about this is the builder can no longer require to be a slim image, right? It can be a non-slim image because it's never running on production. So we can afford to use the bigger base image there, right? So the performance looks like this. So we reduced the image size even further. Our build time got increased by a lot, and our rebuild time as well. Okay, and that is only because that we use from that slim version to the actual bigger version there, and we don't have to run all of that all of those 5 run commands together. Okay, so maybe a nitpick is that packages are downloaded every single time this pip install layer gets triggered. So imagine that you're installing, you're actually building. So every time there is a dependency change, you're actually downloading the packages from the internet. Maybe we can do something about that. Which takes us to our last optimization, which is cache mount. Now cache mount is a newer feature in the Docker build kit. Relatively new. So it basically enables us to use a persistent package cache to be used during builds. This can be very, very useful for packaging for maybe any kind of package manager actually, something like apt-get or pip or npm. So here we are using the mount cache for the pip cache, right? So here you can see that I mount it, and then I install all of the dependencies again. But the good thing is that we don't have to download all packages every time from the web, but only when a new package has been added, right? Okay, so that's good. And now the performance looks something like this. We have the image size. Image size is still the same, but the rebuild time has decreased a lot, and the rebuild time with any dependency change has decreased, and that's only because of that we don't have to download any packages every time from the web. Okay. All right. So to recap, we started with 1.85 gigs, right? That's pretty huge, and most of them are actually coming from the Torch library. Okay. So anytime you have a big machine learning library dependency, this is bound to happen. Okay. So we did a 56% improvement in image size, and that's pretty huge, I think. Then we also did a 30% improvement in the rebuild time with dependency change. Okay, so that's also very good because dependencies can change a lot of times. And that is very great. But of course, just by doing that simple layer ordering, we improved the rebuild time with code change by 98%, and that's something that people overlook quite a bit. I've seen that. Okay, so there are some other best practices I really want people to follow because this will really help, in their own way. Always use a Python-specific Docker ignore file. So we have Python-specific Git ignore files as well, and we also have Docker ignore files on the same, on the same level. So use a language-specific one. It will really help you there. And always separate dev and prod dependencies. You don't need like a full-fledged of dependency tree in your prod environment. Just use what we really need there. Okay. And always use the latest Debian, Ubuntu or Red Hat distribution to base from. This will actually prevent a lot of security and vulnerabilities as well. And you will also get the latest improvement in speed and memory management and all of that. And also try to avoid specifying the Python patch version from the base image. So something like it's very easy to do 3.112.2 in Bookworm. Okay. Now what that will do is that will actually bind you to only that version. You won't get the patch updates. So something like 3.12 Bookworm will just make sure that when 3.12.3 comes back, it will actually download that one. Okay. And this is very ML specific. I would highly encourage you to use a CPU specific versus a GPU specific image. So what happens is usually when I've seen in my company and in my work is that you need GPU for training, but you normally don't need it for inference or for predictions in production. So production like that specifically will actually reduce the size of the image by quite a bit, because Torch actually supports CPU specific and GPU specific images as well, or just the just the wheels as well. So that will be all. I have the code here. I will actually upload everything by tonight. So hopefully if you have any any questions, anything, just feel free to ping me there.
Well, we have lots of questions.
Thank you.
Thank you, Avik. All right, we have lots of questions. You got people excited. I learned some stuff from this, so this is great. So off the top, and if you would unplug so they can set Andy up. Keep the mic. Yeah, there we go. All right, come this way with me. All right. So first off, do you track the size and image build time metrics in your CI/CD flows? And do you have any advice on how teams could start doing that?
Yeah. So I do really, and I've started this practice because otherwise it can get out of hand. Yeah. Okay. So the way I do it is, so there is a time functionality in in Bash. So you can use time and then build the image, and you can put different arguments. So for example, I give no cache. No cache means that you're building it for the first time. Mm-hmm. Okay. Then I just do an echo, echo some change, echo some dependency change. Okay, and then build the image again. That will actually give me what is the actual time taken for that.
Yeah. That makes sense. Awesome. So it's all just kind of manually in your, okay. Any features of Docker that you find not being used as often as they should, like Docker ignore file, excluding files, anything else like that?
Yeah, I think this build cache is something that I've hardly seen. Right, something like this, run cache, which is a newer thing, for Docker. It can be really helpful for Debian-based images, as I said, Red Hat-based as well. Especially for Python, I think, to build the dependencies very quick.
Given pip and downloading is as slow as it is.
Yeah. Especially where you don't have a good internet connection, it really bothers.
Oh yeah. No, I was making notes while you're talking, and that's what I'm bringing back to mess with on Monday. So. Any reason to choose Python Bookworm versus Bullseye or Alpine?
That's the most stable version right now. I think that's the LTS version. So I was using Bullseye before. So maybe I think 2 years or 1.5 years before I was using Bullseye, and then Bookworm came. So we upgraded it. We have to do it, otherwise companies flag some security vulnerabilities on all the time.
Yeah, that makes sense. Have you looked at the use of distroless images as well as new tooling like Rye, UV, kind of some of those newer pieces to help speed up to reduce the footprint and speed up build times?
For some package managers and everything?
Yeah, so as part of speeding up your Docker build using Rye or UV or some of the new kind of faster tooling around.
Yeah. So I think those tools will. So we'll actually see how that turns out. So right now we use Poetry, PDM, Hatch, but when those tools actually support other and better functionalities, we will start using them.
Okay.
That's for sure.
Makes sense. I'm going to give you one more question, and then we'll hand it off to our next group. Do you use VS Code dev containers for local dev?
I do not. So I use something called nix.dev.
Yeah.
Okay. That I use for like deterministic behavior, especially for data science projects and something. That really helps, but I'll try that out.
Okay, cool. Awesome. Thanks again, Avik. Everyone.
Thank you.